Okay, welcome everybody, and thank you for joining the March Alarm Corp webinar. Today's topic is CCTV fundamentals, camera selection and system design. My name is Piotr Doletsky and I'm the National Product Manager CCTV at Alarm Corp. First, a bit of housekeeping. Some of you may not have used the GoToMeeting system before, so if you haven't, let's just run through the details. You will see the GoToMeeting toolbar on the right of your screen. It will show you your own name. Now, you will be muted for the course of the presentation, and we will take questions at the end. Now, just to verify that you can all hear me, can you all please press the little hand icon on your screen just to see that you can hear me? Okay, great. I'm seeing a few hands coming up. Wonderful. Thank you for that. If you want to put those hands down, that's great. Next. Questions. There is a questions tab in the toolbar. You can type in a question at any time during the presentation, or you can save them at the end. Once I finish the presentation, we will go through all of the questions in the order that they are received in. Now, don't be shy, and nobody can see who asked the questions. All that everybody will hear is that what the question was and what the answer is. So I do encourage questions. When you have done a question, please remember to press the send button, otherwise I won't see it. Okay, with the housekeeping out of the way, let's begin. Today's agenda. This webinar will cover the following: types of CCTV cameras, what is a true day-night camera versus a digital day-night camera. We will cover the topic of matching cameras and light sources and some implications for both camera and lens selections, some overall design considerations, and a brief touch on future-proofing installations. With that in mind, let's start on types of cameras. Now, cameras may be classed according to shape or style. So your dome style, which may be internal or weatherproof, it may be a bullet or cylinder style, or it may be a traditional full body or box style which requires a separate lens. The major difference here is that your dome and your bullet style cameras tend to be all in one with the lens already included, and therefore to some extent the choice of the lens made for you. Of course, you can classify cameras according to functionality, fixed or pan-tilt zoom, or PTZ for short. You can classify cameras according to image output. You can have a color camera which outputs a color image at all times, or we can have a day-night camera which outputs a color image in bright light and switches to black and white or monochrome mode in low light. And of course, finally, we can classify a camera according to technology, whether it's an analog camera, in other words, standard composite video output. We can have a network camera which outputs video over an Ethernet stream only, or we can have a hybrid camera which is an Ethernet camera but which also has a composite video output. Now, with those basic definitions out of the way, let's have a look at dome cameras in a bit more detail. Now, it is fair to say dome cameras are the most popular camera in use today, and some of their advantages are that they are compact and discreet. The dome shape with the privacy liner, if available, does disguise where the camera is looking. Installation of a dome is fairly easy. There is no back focus. You just zap in a couple of screws, especially with an internal dome, connect, aim the lens, and off you go. Now, domes today can deliver very good image quality, and there is no doubt that they can be very cost effective. And they may not even require any accessories. However, domes are not without their weaknesses. Now, of course, we do have both internal domes and weatherproof vandal-resistant domes. And the main difference is in the weather sealing and toughness of the housing. However, what are some of the disadvantages of dome cameras? Typically, they are included with a flying lead, which may require on-site modifications. The lens options are somewhat limited, and you typically cannot change on site. There are few domes that go wider than 2.8 millimeters, so the maximum you will typically get with a dome is 90 degrees field of view. So if you need a wider field of view, you almost certainly won't be able to do that with a dome. And also few domes go beyond about 12 millimeters focal length. Now, in the Interlogix range, there is an option which goes from 9 to 22 mils, but in the focal length, but I have not yet really seen a dome with a longer focal length than that. So if you do need to have a very specific or narrow field of view, looking at an object that's further away, a dome may not be the best choice. There is the impact of the plastic bubble on image quality. Now, we are seeing ever higher resolutions in cameras. Even analog cameras today are boasting 700 TB lines, and of course we have megapixels doing 2 megapixel, 3 megapixel, and 5 megapixel cameras. Now that's all well and good with the lens, but the plastic on the dome can have a bit of an effect. And that's even with a brand new bubble or a brand new dome. Maintenance. Once you start to get dust on the bubble, fingerprints during commissioning, or grime building up, you do need to clean it because that is going to degrade the image quality. And of course, cleaning a plastic dome is like cleaning plastic sunglasses. You do need to take care, otherwise you will put very fine scratches into the bubble, and of course that will have a negative impact on image quality as well. So possibly domes are not always the best choice in an environment prone to fast grime or dust buildup. Now the concept of bubble glow. If you mount a camera outside and you get direct glare, either sunlight or artificial light on a dirty bubble, it can make the bubble glow, just like if you're driving a car on a freeway and you get hit with headlights on the back window and your window is very dirty. The whole window seems to glow. So that can make the image unusable at certain times during the day. And of course, because of this factor of bubble glow, you do have some restrictions where a dome can be mounted, and you cannot really shade a dome. So that's one of the weaker points of using a dome, is that it's not always going to deliver a good image at all times. If we look at bullet cameras, typified by this style, they are typically weatherproof and vandal resistant. Easy installation because the lens is included. There is no requirement for a back focus. They can be cost effective and they can deliver good image quality. And other than some mounting accessories, they typically won't require anything. Most, in fact, even come with a mounting bracket. And typically they include infrared LEDs for illumination, which makes them a great choice for low light areas. And many of these have got an included sun shield, which can help combat the glare. However, just like domes, bullet cameras are not without their weaknesses. Again, typically the included flying lead may require on-site modifications. We also have limited lens options. They are not as discrete as a dome. Because of the definite bullet or cylinder shape, you can tell which way the camera is pointing. So if you want a discrete surveillance or more covert surveillance, a bullet is not necessarily the best choice. The issue of maintenance. If you get dust building up on the glass, it will cut down the infrared range, especially at night. So that does need some cleaning to maintain maximum nighttime performance. There is the risk of vandalism, specifically the camera being really aimed. If the camera is sitting on a bracket and it can pivot on the bracket, then if the camera is within range, somebody can tap it and knock it out of alignment, even if the camera itself is not damaged. And the included sun shield may not be adequate to combat glare at all times. Although in this respect, a bullet is probably better than a dome. If we look at pan-tilt zoom cameras, advantages of pan-tilt zoom, because of really high-grade optical blocks being used, they usually deliver much higher image quality than any of the previous cameras. You've got a remotely controllable field of view, and you can zoom in on specific targets within the field of view. And you typically have many housings for flexible mounting, pendant mount, wall mount, flush mount, etc. And of course there are accessories for mounting the cameras off corners, of roofs, of poles, and so forth. However, just like any camera, PTZs also have their weaknesses. They are definitely more expensive than fixed alternatives, and PTZs are really viable only if you have full-time security staff to control the camera. Now, of course, you can set up any PTZ to do automatic tools at all times, program lots of presets, and just have the camera doing preset to preset. However, Murphy's Law usually comes into effect that if something does happen, it will typically happen while the camera is looking at another preset. Now, installation and commissioning of the PTZ usually takes longer because you then need to program the presets and or program the tools. And like with any other dome camera, the plastic bubble requires maintenance. If it gets dirty, you need to clean it, otherwise the image quality degrades. And also the same issue of bubble glow. If you get glare, whether sunlight or artificial light, on a dirty dome, it can make the image washed out and unusable at various times of the day. And likewise, you may have some restrictions where a PTZ can be mounted because of bubble glow. Or you accept the fact that at some times of the day the camera may not deliver a very good image. Okay, full body or box cameras, typified by the image shown here. The advantages of full body cameras is they normally always deliver higher image quality. In some respects, full body cameras are as good as PTZs. You can select the lens to suit the application, which gives you the ultimate in field of view flexibility. Unlike domes, you can go as wide as 2.3 or 2.5 mm lenses, which gives you field of view wider than 90 degrees. Or you can go down to 80 mm focal length to really narrow in on an image further away. Because of the higher electronics being used in the full body camera, they often deliver much better low light performance than a dome. And using the correct housing style with extendable sun shields, you can virtually eliminate them. Not always, but almost. However, full body cameras also have weaknesses. The lens is not included, and this will add cost. Now, depending on the lens, a basic 2mm lens is today quite affordable, but if you need to go wider or much longer, those lenses still carry a certain price premium. You do need to back focus the camera to get the best image quality. And as a minimum, you require a bracket to mount the camera, which is acceptable inside if the camera is not reachable. However, you must use a housing for outside applications. And of course, there are various housings available, some with washers and wipers, etc. The total install cost for a full body camera is typically higher than a dome or a bullet because of the cost of the lens, the cost of the housing, and the installation time. And just like a bullet, a full body camera is not as discreet as a dome because you can tell which way the camera or which way the housing is pointing. And there is also the risk of vandalism or the camera being knocked out of alignment, or in the case of the housing being knocked out of alignment. So there are some of the trade-offs when we look at choosing cameras. It's fair to say that inside, domes are certainly a very common choice, and they do the job adequately. Outside, probably still better off going for a full body in a proper housing to get the ultimate image quality. Although a bullet camera is not a bad compromise. Okay, now let's talk about day-night cameras. A day-night camera can be one of three types. Digital night, sometimes called a soft day-night. You can have a true day-night, which is often labeled as a mechanical IR cut filter camera, or an IR extend camera, which is typified by domes and bullets with built-in IR LEDs. Now, it has to be said that some of these built-in IR LED cameras are mechanical IR cut filter cameras, but many are not. Now, all of these cameras produce a color image in the daytime and a black and white image at night. So what's the difference? A digital day-night camera responds to visible light only. It is not sensitive to infrared. Therefore, you cannot use a digital day-night camera with dedicated infrared illuminators at night. It will not see the infrared. A true day-night camera has a mechanical IR cut filter, which means that the IR block moves out of the way in the night mode. So this camera responds to visible light in the day mode, and it responds to visible light and infrared light in the night mode. So you can use this camera with dedicated infrared illuminators. Then, of course, you've got the IR extend day-night camera. They respond to visible light and some infrared light at all times. They produce a color image during the day, but sometimes in bright sunlight, the colors are a little bit muted or a little bit washed out. And often they can produce a slightly blue tinged image at night under the infrared. So the image is not always a full black and white. And this does vary a little bit between various infrared cameras. Okay, we've talked a little bit about cameras. Let's talk about the most important aspect of video surveillance, and that's light sources. In this context, when we talk about light sources, it really doesn't matter whether we are talking about an analog camera or IP cameras, because we're talking about what happens in front of the lens. Now, without sufficient light, there can be no CCTV. It's a fairly obvious statement, but it's important to remember that. Now, light sources can be natural, i.e. sunlight, or artificial. Now, sunlight is a very good light source. It's abundant, and it's free. It has very good color rendition, also known as CRI, and this is a topic that I will cover in a little bit more detail in the coming slides. Now, what makes sunlight such a good light source is that you can see in the spectrum plot, sunlight consists of a mixture of all the colors of the rainbow, and it's a fairly flat distribution. Now, sunlight has got its limitations. It's not on 24 hours a day, and you can't store it. Sunlight being completely natural, the intensity is variable and the quality is variable. It depends on time of the day, it depends on cloud cover and weather conditions. Now, the changing position of sunlight can cause shadows and glare. As you can see here, an image with shade, no sun, or an image with lots of sun and therefore shadow areas with little detail. And the changing light quality can cause problems with color reproduction. Sometimes the image appears more red, sometimes the image appears more blue. Now, most cameras with auto tracking white balance can compensate, but if color accuracy is paramount, it's worth keeping that in mind. And in some applications, you do need to know the exact color. Okay, artificial light sources. Let's discuss the types of artificial light sources that are available. We can classify light sources as light sources. In other words, they produce visible light, and infrared, as typified by halogens, as halogen downlights, in the old-fashioned incandescent light bulb, or a floodlight. They are ideal for day-night cameras that are sensitive to IR. We can have cold light sources. These produce visible light only with no infrared component. Examples of cold light sources include white LEDs, compact fluorescent bulbs, and of course the good old-fashioned long strip fluoro tube. Now, you can use them with all color or day-night cameras, but they do have some performance implications, which we'll talk about later. And of course, we have dedicated infrared light sources. We produce monochromatic single wavelength infrared, which is invisible to the naked eye. And an example of this is a Siemens CL 50-30, which is an adjustable angle infrared illuminator that goes up to 100 meters. Now, if you do decide to use infrared light sources, you have to use a camera that is sensitive to infrared. Now let's explore artificial light in a bit more detail. The strengths of artificial light as applied to CCTV, it's controllable. We can select the intensity. We can select within limits the position of the source. As you see here in this example, we can control the luminaire. We can control how the light is spread by the light source. So we can control the distribution as well, and we can control where we choose to mount the light source. Artificial light can be on 24/7, so therefore the lighting can be maintained at a constant level, and this is particularly important inside. However, as with all things, artificial light sources do have some weaknesses. It costs money to run artificial lighting, especially energy-intensive halogens. It requires maintenance. You need to replace globes or tubes to clean the luminaires. All of you who've worked in an office would be familiar with the procedure where once a year electrician comes through, replaces all the tubes, replaces all the ballast, and replaces all of the diffusers. Now, in an office, this is fairly easy, but try doing that on a light pole which requires cherry pickers or scissor lifts. It adds cost. Now, the costs of green lighting, such as white LEDs or infrared LED light sources, which are more energy efficient, at the moment is still quite high relative to incandescent. And the color rendering index of artificial light sources is almost always worse than sunlight, which has an impact on color accuracy, which we will discuss a little bit in the next few slides as well. Now we see here a typical example of what happens with artificial light. Eventually all light sources wear out, they do need replacing. And of course, there is an upfront cost to install the light in the first place, which must be budgeted for. And we will also look at this in a little bit more detail. Okay, the concept of color rendering index, or CRI, this is a measure of color accuracy. In other words, how well the light sources reproduce colors. Sunlight is the ideal light source. Its CRI is deemed to be 100%. So sunlight gives you the most accurate color reproduction. And again, this is because the spectrum of sunlight contains all of the colors in fairly even percentages. Now the CRI depends on the emitted light. So the more complete the spectrum, the higher is the CRI and therefore better colors. Now the implications for CCTV are obvious. If you see a suspect, what color was the car or the jacket or the jumper that the suspect was driving or wearing? Was it red? Was it orange? Or was it yellow? Light with lower CRI blends colors together. And a good example of this is we see here the traditional sodium vapor street lamps, which render everything very orange. And under sodium vapor street lights, an orange car looks very much like a red car, and even a white car might look orange, as an example. So some sample CRI of various light sources. You can see that the low pressure sodium is very poor. High pressure sodium, which is a little bit better. The typical office fluoros that are used are at around 6. The ceramic metal halides, which is typically used on sports stadiums, has a very good CRI, and halogen incandescent is actually also very good at rendering colors. Now to look at the impact of color rendering index, we see here on the left a light source with a fairly complete spectrum, and you see the color patches being discernible as each one a fairly unique color. Even the two purple patches are set, and you can make out that they are two slightly different colors. If you look at a fluorescent lamp, typically fluoro, you will see that the colors are slightly distorted, that all of the colors look a little bit different, and that already we see some of the colors are blending into each other. And finally, if we go on to the sodium street lamp, you will see that all of the colors, with the exception of orange, are distorted, and the yellow, and pretty much everything is either orange or red. So again, if you have an application where you need very accurate color reproduction, you do need to pay attention to the light source that's being used. Now, how do we choose a light source? In an ideal world, we can choose the light source before we design the system. Now, I know that that's not always the case. But you would look at the size of the area to be lit and the light distribution, i.e. flood light or spotlight. The required lux level, and this has implications for camera sensitivity. If you have a very sensitive camera, you can get away with lower light levels. If you know your camera is not very sensitive, then you need to increase the light level to get a good image. Whether the light is to be visible or invisible infrared. The level of aggressivity or over-illumination. Now, aggressivity is sometimes used as a security technique if you make your facility very brightly lit, that can act as a deterrent to intrusion. On the counter side to that is the allowable light pollution or light trespass. In other words, lighting an area that you do not intend to light. And those of you who have ever lived next to a sports stadium that's being used to play night matches will know all about light trespass or light pollution. Of course, there is the budget for both the installation and the running costs, and there are the maintenance issues which we already discussed, and the issue of color accuracy. There we go, there's an example of a light stadium, and you see what I mean, that is a good example of light pollution. Now, visible or infrared? Only visible light can provide color surveillance. Infrared will provide either black and white or a greeny black and white with false colors. Now, depending on application, this may or may not be legally permissible. Visible light shows you which areas are lit and which areas are in shadow, which can aid an intruder because he knows where to hide. Infrared light is covert in this respect. because you cannot see which areas are illuminated. However, if a culprit or intruder crosses an area that's lit with visible light, he will be silhouetted, so visible light can be a deterrent. However, as we said earlier, residents may complain about light pollution. Infrared is invisible, so there is no light pollution, but with infrared there is no silhouetting, and therefore there is less deterrent value. So these are the factors that need to be taken into account when choosing a light source for a given application. And here again we see an example of an infrared camera at night in our office, and you can see here that everything is either black or white. We do not see any more colors. Okay, let's look at the efficiency of artificial light, and this is going to become more and more important as the cost of energy increases. Traditional incandescent or halogen light sources are least efficient with respect to energy usage, and they also have the shortest life, but they also have the lowest upfront costs, and as we saw earlier, they tend to have very good color rendering indexes. So they're very good as from a color production perspective. Compact fluorescent light bulbs are more efficient. They have longer life expectancy, but per bulb there is a higher upfront cost, and the CRI is still not quite as good as a halogen. However, with compact fluorescence, it's relatively easy to replace an incandescent light source with a compact fluoro. Now let's look at white LED lighting. White LEDs, or LED lighting in general, is becoming rapidly more popular. LEDs have got much higher efficiency and life expectancy than compact fluorescent lights, up to 10 years or more. However, at this stage, much higher upfront costs, although this is expected to decrease. There are limitations on retrofitting LED light bulbs into existing fixtures or luminaires. There aren't that many choices. Again, hopefully this will improve in the near future. However, at this stage, the color rendering index and color consistency of LEDs, particularly high-powered ones, needs to improve. They're often very blue. And to give you an idea, this is a light spectrum of a typical white LED, and you can see that the spectrum is not as flat as we would want in an ideal light source. And then the next photo, here we have a selection of white LED flashlights. Now, they're all white LED, but notice that they are all a completely different color. And that is still one of the issues with white LED sources, that the color accuracy can still not always be as accurate as we want it to be. Okay, matching light and cameras, bringing it all together. If the lighting solution is based on fluorescent tubes, white LEDs, or compact fluorescent, then we're best off using either a color or a soft day-night camera, because since we don't have any infrared component, a true day-night camera will not provide any real benefit at night while being more expensive. However, if the lighting solution is halogen, then we really want a true day-night camera, because it is the best choice, because once the camera switches to night mode, it will make use of both the visible component and the infrared component emitted by the halogen. And we will look at it later in a bit more detail. However, both color cameras and a soft day-night camera will also work. If the lighting solution is dedicated infrared, then we must use a true day-night camera or an IR extend camera, because a color camera or a soft day-night camera cannot see infrared. So they are not compatible. Of course, if we require color video at all times, then we must ensure that the light level is sufficient and that the light source has an adequate CRI for the purposes. Now, I think it's worth looking at how cameras actually respond to light. Here we have the light spectrum of a typical halogen lamp. This could be one of those MR16 halogen downlights, which are very popular in offices and homes, or this could be one of those long tube halogen floodlights. Now, I said earlier that halogen lighting is not particularly efficient, and the reason for that is, notice that the vast bulk of the output is in the invisible range. In other words, it produces much more infrared than it does visible light. And of course, that is a consequence of the fact that we are heating up a metal filament and trying to get it to emit light. Now, what are the implications for video cameras? Well, this bit here, as we said, is invisible. If we have a camera that is a color camera or a day mode, it will only respond to the visible light portion. If we have a true day-night camera, which switches to night mode, at night it responds to both the visible light portion and a good chunk of the infrared. A soft day-night camera, on the other hand, would still only be responding to the visible light. And an infrared extend camera, like a True Vision IR dome, responds to a mix of visible and some infrared, although not as much infrared as a true day-night. So this is why one of the key reason why you would want to use a true day-night camera with a halogen lamp, because it just makes up all the visible light of both the visible light and invisible light that's being emitted by the halogen light source. Okay, lenses. Now this is obviously in the context of full body cameras. Good lenses are critical to good images, and in this case again it doesn't matter whether we are talking an analog camera or an IP camera. Not all lenses perform equally well. Depending on the construction, and most lenses are multiple elements, a good lens will pass all of the light back to the sensor, whereas a badly constructed lens will have a lot of internal light scattering. This will have two consequences. First of all, the image will not be as bright with a poor quality lens, and also if you have glare shining into the lens, a bad lens will compound the problem and may also cause washed out or unusable images. Today most lenses are aspherical to compensate for various aberrations. And of course, many lenses these days use what's called low dispersion glass to also produce sharper images without color fringes. Now, at the moment, many new installations are using megapixel cameras for the higher resolution. Megapixel lenses are critical. You have to match the lens resolution to the camera resolution. In other words, if you've got a 2 megapixel camera, you want at least a 2 megapixel rated lens. You would not choose a 1.3 megapixel lens for a 2 megapixel camera. And finally, infrared. Normal lenses cannot focus infrared light to the same focal plane. So if you use a normal lens with a true day-night camera and you have a halogen or a infrared light source, at night the light will be out of focus. And this is the difference between a normal lens and an IR corrected lens. So bear that in mind. However, to put that in another way, if we are using a soft day-night camera, which does not have a mechanical IR cut filter, then we don't really need a day-night lens because it's the camera is not responding to the IR. Okay, now let's talk about future-proofing installations. We just talked about light and cameras. As I said earlier, this applies to both analog and IP cameras because we're talking about what happens in front of the lens. Now what about transmission? We know that analog video can be transmitted over coax, Cat5, UTP, or optic fiber via the use of suitable converters. Now we know IP video is typically transmitted over Cat5, UTP, or Cat6, or optic fiber. However, you can even transmit video, IP video over legacy coax. And that's what I mean about future-proofing in installation. Let's look at an example. Let's say we are putting in a new system, but due to cost considerations, we want to go analog today with a path to upgrading it to IP video in the future as IP cameras become more affordable. If we are running RG59 coax, then the cable length is really not going to be an issue for future upgrades. Let me explain. Typical maximum cable run for RG59 coax is going to be about 150 meters. Usually you try and keep it less than 100. We put an analog camera in with an analog DVR, and there is a very simple analog video system. But let's say we want to replace the camera at a later date with an IP camera, and we want to keep the same cable. We can actually do that. We want to put in a network switch, and we want to put in an IP camera with an NVR. We can use something called an IFS-MC coax, which converts the video, converts the Ethernet signal for running over coax. So we run our Cat5 cable from the camera to the converter, hook it up to the coax cable, put another one at the other end, put in another cable back to our network switch, and hey presto, we now have a network video solution running over legacy coax. And the major benefit of that is for a couple of low-cost converter boxes, you do not need to rerun the cable. And often in installations, rerunning the cable is going to be the most difficult or the most expensive aspect. Now, what happens if we decide to install Cat5 or Cat6 to begin with? And we want to run analog video initially, and we want to upgrade to video over IP later. Now, this is where things get a bit more complicated. We know that with video transmission, analog video transmission over Cat5, if we use active receivers, we can go several hundred meters. However, if we want to upgrade that cable to IP cameras at a later date, we must keep the cable on to less than 90 meters, because that is the maximum cable run we can have in an Ethernet network. Otherwise, you will need to add hubs at a later date. If we cannot keep the cable on to less than 90 meters, then either we can put in coax and then run IP video over coax, or we use optic fiber. So here we go. Here's another example. We have an analog camera. We want to run it over Cat5 coax. In this case, we have 90 meters. And we want to run it to a traditional DVR. We take a couple of low-cost video balance available from the IFS product range, and this will give us very good quality video transmission over a Cat5. Now let's say we want to then upgrade that at a later date. We still have the same Cat5 run, same length. We put in a network switch, so we simply terminate the cable with an RJ45. We put an IP camera in the field, and we add our NVR. And this shows you how easy it is to actually future-proof an installation, either whether it's coax or Cat5 UTP, and migrate from analog to IP video at a later date. Conclusions. Planning a surveillance system is critical to success. Understanding the strengths and weaknesses of each camera type and selecting the best one for the given application. Understanding the importance of a correct lighting solution to match the camera being used to the light source in operation and the application. And just to recap there, we know that if we want to have color accurate images, we need to use visible light. If we are not concerned about color accuracy, we can use infrared light at night and put up with black and white images in low light conditions. And also understanding that we can, to some extent, future-proof an installation to easily upgrade from analog to IP at a later date. Okay. Would you like to know more? More information, including brochures and data sheets, may be found on our website. If you haven't done so already, I would urge you to subscribe to the Alarm Corp Pulse to receive new product information automatically. If you register online with our e-store, you can get full access to the e-commerce platform, including your own customized pricing and order placement. Please feel free to contact your nearest Alarm Corp representative, Jeff Rushton in New South Wales, Diane Brazil in New South Wales, and Stephen Dinger in Victoria and South Australia. Or contact myself directly. My number is 0421 378 334, and my email address is shown there. So I will happily respond to either phone calls or questions. If you enjoyed this webinar, there will be a regular webinar every month on a Wednesday. Some of the topics slated for this year include the iPhone as a surveillance tool, another session of CCTV fundamentals looking at network video system design, optic fiber fundamentals. This was a very popular topic last year, so we will rerun the topic with a few changes and a few additions, optimizing DVR configuration, and remote video monitoring. And this is on top of more product-specific webinars as well. Please go to our website, click on the resources webinars link, and you will see the full list of topics. We look forward to your participation. If you haven't visited our website yet or in a while, please take a look. In case you didn't know, we can now also supply both coax and network cable. Okay, now over to question time. Please use the webinar feature to submit questions. and remember to hit the send button. Over to you. And thank you for your attention. Okay, first question was to do with optic fiber. Just to clarify, Alarm Corp can supply the full range of IFS optic fiber transmission products, single and multi-channel as well. A lot of those products are already shown on our website. If you need any more information, please contact myself or one of my colleagues. Okay, next question asked about video over IP, whether or not we can also supply network switches. Yes, we can. We have quite a big range of network switches in both normal and PoE fibers, as well as industrially hardened variants for use in high temperature environments. Again, those products are available on our website, and if you want any more information, please email me or one of my colleagues. Okay, if those are all the questions, then look, thank you very much for your attention. I hope the webinar has been useful to you. If you think of a question at a later date, please email me and I will respond to you in a quick and timely manner. Oh, here we go. Right. The question is, do you offer site audit and recommendations? It's not something that we do on a full-time basis. However, we do that with a customer. If they ask us to help them design a system, then yes, we can come out to site and offer advice. And that's always done on I guess, project-by-project basis. But we can do that. Okay. Are there any more questions? Okay, in that case, I will once again like to thank you all for your attention, and I hope to see you on the next webinar in April.